Just going to give everyone another minute to log on and then we'll get started. Good afternoon, everyone, and welcome to the webinar entitled The Basics of Perimeter Fire Containment. My name is Christina Larkin, and I will be one of your moderators, along with John Zalepka, who is our Training and Development Manager. We would like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We will be disabling the chat feature during this session. Questions can be sent in the Q&A section at the bottom of your window. We will be gathering your questions throughout the webinar and will hold a question and answer discussion at the end. We will be reporting AIA credit for those who attend at least 75% of the live webinar. If you have an AIA number and did not give it upon registration, please send it to webinars@stifirestop.com. If you are not a member of AIA, STI will be sending certificates of attendance for you to self-report to whatever agency you wish. We will also be sending a recording to all who registered. Please allow 7 to 10 business days for the generation of certificates and recording.
Thank you, Christina. Our presenter today is Mike Zanatelli, STI's curtain wall and facade specialist for the Western U.S. region and Western Canada. Our program, The Basics of Perimeter Fire Containment, was designed to enable you to fully understand the different aspects of today's complex curtain wall configurations and perimeter fire barrier systems, as well as the role that codes, standards, and tested fire stop systems play. And with that, Mike, the floor is yours.
Thank you very much, Christina and John. Much appreciated. So depending on where you are today, good morning or good afternoon. I would like to welcome you to today's Perimeter Fire Containment training. Everyone at STI appreciates you taking the time out of your day today, and thank you for the opportunity to speak with you. Again, my name is Mike Zanatelli, and I'm part of the curtain wall team here at STI. I currently handle the Western region of the US and Western Canada. Later in the program, I will introduce the other members of our curtain wall team and discuss the services that STI and our team provides. I think Christina already went through everything we need to know about the AIA credits. We'll take care of that as the program ends at the top of the hour. Just a little housekeeping, another housekeeping item. Obviously, this presentation is subjected to copyright protection. The use of any images or content may not be used without written consent from STI Firestop. Today's presentation has been developed to assist you in understanding the requirements of perimeter fire barrier systems and how to avoid costly headaches and delays during design and construction. As we progress through the presentation, please feel free to submit your questions in the Q&A, and some questions might be answered by John and Christina directly, but the majority of them we will address at the end of the presentation so the entire audience can benefit. As the construction of high-rise buildings continue to reach higher and higher throughout the world, perimeter fires or curtain wall fires continue to be an increasing problem. The recent fire in London has changed many of the codes worldwide and has made an impact on how people protect high-rise structures. Unfortunately, we continue to have fires on a regular basis. Some examples of high-rise fires with injuries, deaths, and property loss in 2020 include fires in Hawaii, Chicago, Los Angeles, New York City, and the most recent one in South Korea just 2 months ago. Our discussion topics will cover the following: a brief introduction on what curtain walls are, the evolution of code consistency, the importance of testing for perimeter fire barrier systems which also includes a detailed overview of the ASTM E2307 standard and the ISMA, and also understanding how to read tested design systems. We'll talk about designing and installing for success, which will include key design and installation points for non-backpan aluminum frame systems, and also meeting the next set of challenges. And then towards the end, we'll do a quick STI update on what we've been working on. And then obviously we'll have a Q&A session at the very end. So what are curtain walls? Curtain walls are non-structural, non-fire rated walls most commonly found in commercial, multi-story, or high-rise construction. They serve as an exterior skin that provides protection from the elements and helps to provide a comfortable environment inside the building. Curtain walls can have many different appearances, but its main characteristics are narrowly spaced vertical and horizontal aluminum framing with glass, stone, metal, or composite panels. So what does non-structural refer to? Curtain walls are rigidly attached to the floor slab with some type of an anchor system. So the curtain wall facade does not carry any dead load weight from the building other than its own dead load weight. The curtain wall transfers wind and gravity loads to the main building structure through connections at the floor or columns of the building. Since the curtain wall is non-structural, it can be made of lightweight material such as aluminum, which will reduce the construction costs. Let's review the components of a traditional aluminum frame curtain wall system. Obviously, we have our concrete slab. And first you'll have the anchor system, which will be located either on top of the slab, the edge of slab, or completely under the slab. The curtain wall framing will consist of vertical mullions and horizontal transoms. The spandrel areas can be glass, metal, stone, or composite panels. And last is obviously the vision glass. Let's briefly discuss the evolution of code consistency. A good starting point is always to have a solid understanding of the code requirements. In the perimeter fire barrier world, we use the 2012 IBC as the version of the code that outlines the requirements of the new ASTM standard, which has eliminated much of the confusion of earlier code versions. The great news is the codes have finally established consistency with the adoption of the 2015 and 2018 IBC codes, as well as multiple state codes being revised. The 2012 code adopted specific language to outline the requirements and further eliminate confusion that future versions have built upon. As you know, the protection of voids is mandatory in all building codes, with the IBC addressing specific ASTM E2307 requirements. Section 715.4 addresses the voids created at the intersection of the non-rated exterior curtain wall and a rated floor or roof slab to prevent the interior spread of fire. Voids are to be sealed with an approved system to prevent the interior spread of fire. These systems must be securely installed, i.e. mechanically fastened in place. The systems must be tested in accordance with ASTM E2307, which we will cover in detail shortly. And they must provide an F rating equal to the floor or roof deck. Canada has also adopted the ASTM E2307 standard requirements into the 2018 S115 Canadian Code. The adoption of the ASTM E2307 requirement into the Canadian Building Code was delayed due to the pandemic, but is scheduled to formally happen in 2021. This slide is taken from the 2018 S115 code. As you can see, the ASTM E2307 standard is referenced in Section 9 as the standard test method for perimeter fire barriers using the ISMA test apparatus. In the next section, we will discuss the ASTM E2307 standard and the ISMA in great detail. So let's get into our discussion on the ASTM E2307 standard and the ISMA, as well as understanding how to navigate through a tested system. So what is ASTM E2307? STM E2307 is a standard test method for determining fire resistance of perimeter fire barrier systems using the intermediate scale multi-story test apparatus, or ISMA. This is a very severe and difficult test to pass, and it differs in three critical ways from how standard construction joints are tested. These assemblies are tested between a rated floor or roof barrier and a non-rated exterior curtain wall assembly. This test method measures the performance of the perimeter fire barrier system and its ability to maintain a seal to prevent fire spread during the deflection and deformation of the exterior wall assembly. The curtain wall and the joint are burned from below and also from the exterior to mimic how high-rise fires perform. Compartmentation is a key component of fire life safety. This is the process of dividing a building space into smaller units by constructing rated boxes to limit the fire spread, toxic smoke, and gases to their point of origin. This allows occupants to get out and first responders to get in. Obviously, this is critical in fire life safety, but in curtain walls, structural integrity is just as critical, because if the wall comes off the building, the joint will go with it. So we must protect the key components of a non-rated curtain wall system as long as possible. The fire will attack any voids at the floor line on the interior side while breaking out the vision glass on the floor above, the floor below. The fire will also attack the framing system, which is typically constructed of aluminum. Again, if we don't protect the critical components of the non-rated curtain wall properly, the entire wall will fail. Let's take a look at some pictures of a project that we were involved with. If you look at the spandrel panels, you can see exactly where the most severe area of the fire was. On the right, you can see the panel starting to melt. On the left, you can see the panel's gone and only the spandrel insulation is left. Moving further to the left, you can see the section of the spandrel and safing insulation at the floor slab that has been held in place by the stiff back angle. On the floor where the fire broke out, you can see the failure of the wall system, which is exactly what will happen in a fire. The aluminum framing, vision glass, and spandrel panels are completely gone. But on the floor above, the anchor and the aluminum framing are all intact and protected. So in this case, the perimeter fire barrier system did its job. It's important to note how critical and severe the ASTM E2307 test standard is for perimeter fire barrier systems by looking at the ASTM E119 time temperature curve used during the test. Note the melting points of rigid foam panels at 300 degrees, spray foam at 392 degrees Fahrenheit, zinc will melt at 790 degrees, and aluminum alloys begin to soften at 865 degrees Fahrenheit and will melt at 1220 degrees Fahrenheit. So if we are running a 2307 test at a third-party lab that consists of aluminum framing, we will start to lose the lower framing members just 9 minutes into the test. And we are just starting a critical stage of protection that must last for another 1 hour and 51 minutes. So let's take a look at the impact of the 2307 test and the ISMA on a recent test that we conducted. On the left, you can see the multi-story wall prior to the start of the test. On the right, you can see the very start of the test with the internal burner just lit. Here you can see the internal burner gaining intensity very quickly from two different angles. In this photo, you can see the internal burner really cranking around 5 minutes into the test. Next, the exterior burner is lit. The test begins to ramp up quickly, and the wall is now under attack from fire on the interior side and the exterior side. And here you can see the intensity of the test has progressed significantly, and we start to see flames as high as 14 feet. At this point, we start to see critical components of the wall start to show fatigue under the temperature and pressure of the time temperature curve. As we talked about earlier, roughly 9 minutes into the test, you can see on the left of the lower horizontal framing or transom starting to melt, deflect, and twist. Moments later, you can see the lower framing of the wall giving way as the flames eat through the wall system. To document the extreme heat and pressure of the full-scale ASTM E2307 test on the ISMA, you can see the vision glass used in this design has melted and is running down the exterior of the wall assembly. This is not a common occurrence as the glass generally breaks or shatters during the test, but does demonstrate the extreme temperatures the wall is subjected to. Here you can see the impact of the ASTM E2307 standard at the end of the test. Critical components of the wall system have been lost and the assembly is glowing red hot. Here you can see the impact of the vertical framing system at the floor line and anchor system, which is in direct correlation to the location of the exterior window burner. It is important to note that the wall will twist, warp, and come apart at the floor slab. The key is to maintain integrity of the wall system at the anchor points at the floor slab, and then maintain integrity of the wall system above the floor slab. Once we have passed a successful test at the third-party laboratory per the ASTM E2307 test requirements, a test is published. Both Intertek and UL test to the same ASTM E2307 standard, but there are unique aspects to both laboratories. UL has the ISMA configuration for backpan designs, anchors tested in designs and realistic movement requirements. Intertek has testing for all vision glass, hybrid window walls, and wider mullion spacing. We use the best aspects of both labs in our tested designs to give us the ability to produce real-world perimeter fire barrier systems. Once you have a successful test, you are given a system number. Each lab has an alphanumeric numbering system. It is pretty simple to understand how these systems are labeled once you've read through a few. I'll quickly break down what everything means in a UL system, and then we'll take a look at an Intertek system. For the perimeter fire barrier containment testing, the first two alpha characters are CW, which stands for curtain wall, which means this assembly was tested per ASTM E2307 on the ISMA. The second set of alpha characters will be an S or a D, referring to either a static or dynamic design. Please note that in a perimeter fire barrier system, a static system is completely acceptable. Most people are familiar with the static and dynamic movement of head of wall joints, where the dynamic movement is either compression or extension. In a perimeter fire barrier system, the movement is a 5% vertical shear, which moves up and down the building. The numeric component addresses the gap width in the system and the test number in that series. The first number references the width of the gap between the curtain wall and the edge of slab. So the 0 series are for joints up to 2 inches. The 1000 series are for joints up to 6 inches. And the 2000 series are for joints up to 12 inches. The last three numeric components list the test number in a series. So this assembly is the 41st test run for a perimeter fire barrier system for a joint width of max 6 inches as tested per ASTM E2307 on the ISMA. One more thing to note, the last 3 digits are a sequential proprietary numbering system that is unique to a manufacturer who passed the test. At Intertek, they label things slightly differently. So our system STI BPF 120-04 is broken down as follows. Obviously, STI is the company or manufacturer identifier. BPF stands for Barrier Perimeter Fire, which is obviously tested through ASTM E2307. And the 120 stands for 120 minutes, which will get you a 2-hour F rating. and the 04 is the force system in this test grouping. Having a strong pedigree of tested systems to choose from is critical in the design phase or installation phase of perimeter fire containment systems. The value of tested systems are always recognized and respected by architects and inspectors. It will limit the project delays by eliminating any concerns. It will also save money by keeping the project on or ahead of schedule and limit liability and exposure. And as we have discussed, tested designs will obviously work in real fire conditions. Let's continue our next section, which is designing for success. In this section, we will discuss the key design and installation points for non-backpan aluminum frame designs and wrap this section up with some of the challenges that we are consistently facing and how to address them. So in this section, we will discuss the requirements of the components of a tested design, including the following: why we use light gauge metal for spandrel insulation attachments, the proper orientation of the mineral wool in the safing slot, the role of mullion covers, and the role of the tested fire stop spray. Every tested system for aluminum frame designs require 5 basic features. Spandrel insulation is mechanically fastened to the frame or steel backpan. A stiffener or reinforcing member to be installed behind the spandrel insulation to maintain the compression of the safing in the void or safing slot area. The mineral wool in the safing slot or void is installed with the grains running vertically and to the required compression listed within the system. Mullion covers installed above and below the floor slab if required, and the safing shelf installed on the backpan designs per specific system requirements. And obviously the installation of the tested fire stop coating will be shown in the UL system, as shown in the UL system. So why do we use light gauge metal, hat channel, or insulation in tested designs? Light gauge metal is required for the following reasons: fastening the spandrel insulation in place to maintain the integrity of the wall system in a fire. It meets the 715.4 code requirements of securely installed, and they are required by all UL and Intertech tested designs. Here you can see the role of the light gauge continuous angle that is fastened to the framing, and the spandrel insulation is secured to the angle with drywall screws, fender washers, or cup head weld pins per the system requirements. Note the melting of the vertical mullions and the bowing of the frame system at the bottom where the transom has burned out. There are many tested options, including installing a continuous angle. Hat channel is another option, and various types of insulation hangers. The development of high-performance insulation hanger systems are changing the way spandrel insulation is installed in the shop and in the field. These new systems provide substantial labor savings. The designs have major advantages over traditional methods, including the fewest number of screws installed into the framing system, or in many cases, no screws at all. This allows proper internal drainage within the system. These systems excel in wall systems where there are steel liners inside the mullions or blast-proof walls with steel reinforced mullions. Light gauge metal is also used to support the compression requirements of the mineral wool in the void or safing slot. Please note the spandrel insulation is not fastened to the angle. It simply sits behind the spandrel insulation. You can see a galvanized angle used on the left and hat channel used on the right. Typically, they are located 2 inches from the top of the floor slab. Here you can see the stiffener keeping the compression of the mineral wool in the void, even as the curtain wall framing comes apart below the floor slab. The proper orientation and compression of the mineral wool in the void or safing slot is often misunderstood. On the left, you can see the proper method with the grains running vertically along the slab. And on the right, you can see the incorrect method with the grains running horizontally. This is a key component in a compliance system and very critical before any spray should be applied. You can see the two images on the right of the grains running horizontally do not compress and buckle, which will cause fatigue to the joint system. In the images on the left, you can see how the mineral wool is turned with the grains running vertically. The mineral wool compresses like an accordion, allowing the mineral wool to rebound against itself to maintain proper compression within the system. Please note that when mineral wool is installed correctly, there are no additional supports or old-style insulation Z-clips needed to support the safing. Our current systems are tested up to a max 10-inch wide gap with no support. Let's take a few minutes to talk about mullion covers. Traditionally, mullion covers have been used to provide a bridge between the spandrel insulation and the exposed mullions. They are designed to stop the transmission of heat through the mullion to the knee wall. The mullion covers are cut from foil-faced spandrel insulation and installed above and below the floor when necessary and through the safing slot. There have been many advancements lately in the requirements for mullion covers. Many of today's high-performance tested designs only require mullion covers below the slab. In some cases, mullion covers are not required for the fire test. They can simply be added for thermal requirements when needed. It is always recommended to refer back to the tested design for specifics on mullion cover requirements. Let's quickly go over the role of the fire stop coating. This is the final step in a compliant design that acts as a glue to keep the system intact on the top side of the floor. Most importantly, it stops the propagation of smoke and fire through the mineral wool in the safing slot. Stopping smoke will certainly save lives when you have a compliant system. But we continue to see damaged or incorrect installations quite often. This could be due to spray damage because of exposure to water before it is cured, hard brittle compounds that crack once cured, incorrect caulking that have washed out due to water exposure, and untested solutions like simply stuffing pieces of mineral wool insulation into the void. As you know, 70% of all fire-related deaths are due to toxic smoke and gases. Most occupants have already perished from smoke inhalation by the time the flames reach them on the upper floors, so installing a compliant system is obviously critical. Our last section is meeting the next set of challenges from curtain wall consultants, architects, and code officials. As we discussed earlier, anchor protection is very critical in the protection of perimeter fire barrier systems. Remember, if the anchor fails, the entire wall is going to go with it. UL has adopted testing requirements in the XHDG guide for all manufacturers that require dead load anchors exposed to direct fire must be protected. These anchors must be protected for the hourly rating of the floor slab. UL has also adopted a new category, the XHDI guide, that clearly defines what is an acceptable level of anchor protection. This is a mandatory requirement of curtain wall consultants and designers, and the codes are adopting language to incorporate a consistent requirement. Here you can see two examples of protecting the components of a top of slab anchor on the left and a face of slab anchor on the right. In some cases, we can allow the fist slider assembly to extend below the safing a maximum of 2 inches without additional protection, which we have in our UL system CWD 1044 and CWD 1045. While other designs fully encapsulate the anchor system, allowing the mineral wool to extend below the floor slab by a max of 2 inches, as detailed in our UL system CWD 1054 50, which you can see on the right-hand side. In conditions where the anchor plate or assembly is fully exposed on the underside of the slab, specific solutions were needed to pass the rigorous test standard. Here you can see an anchor protection product that is simply shot into the deck from below, providing complete protection of the anchor. UL has also started to publish specific tests incorporating these new requirements. For example, our UL system CWD 1032 is the only tested design able to treat a fully exposed under slab anchor system. One quick note before we proceed. Because the glazing manufacturers and glazing contractors have all types of anchor systems, our curtain wall team spends the majority of our time assisting the curtain wall consultants, architects, glazers, and fire stop contractors in the proper protection of their anchor systems to ensure that the entire wall stays intact in the event of a fire. Unfortunately, we are brought in too late on some projects, and due to a variety of reasons, it can be difficult to address the anchors properly. So regardless of whether you're a general contractor, architect, blazer, or fire stop contractor, please feel free to get us involved early so we can collectively address the anchors properly. Another issue that has become of great concern for code officials, architects, and curtain wall consultants comes from the use of newer framing systems. Here you can see an example of what's called a single chicken head design. This design creates an opening in the face of the frame at the stack joint. This will allow smoke, toxic gases, and flames to travel inside the mullion vertically to the floors above. The proper way to address this is to use a specific type of mullion plug that has been tested in these conditions. An important point to note is that the mullion plug would have to be shop installed during the fabrication of the units, because once the units are set, there is no access to the vertical mullions. And before we end this section, I just want to emphasize, just like anchor protection, our curtain wall team spends a lot of time addressing these situations also. I know there's a colleague of mine on the webinar today who was involved in a project that had this exact condition. It was not addressed prior to the units being set, and unfortunately, all the vertical mullions at the stack joint on the entire project had to be cut open and addressed after the fact. So again, please feel free to get our team involved as early as possible so we can properly address these conditions for you. So this ends our AIA section of today's presentation. We're pleased to present or provide an update on what STI has been working on recently in the last year and a half or so. So basically, we want you guys to know that you're not alone in this process. STI is your global fire stop solution partner. We own about 60%, probably a little bit more now, of the perimeter fire barrier systems tested at UL and many more at Intertech. But having the greatest number of systems is certainly not enough. As we talked about, it's all about real world testing. STI has developed complete tested solutions for backpan, non-backpan, all vision glass, and hybrid window wall designs. But that still isn't enough for today's modern and complex projects. We also offer complete tested coverage for precast, EIFS, and GFRC designs. We have also invested in the development of the industry's most successful products for perimeter fire containment, including water-based and all-weather high-performance fire stop sprays for perimeter fire containment. We have the Quick Clip system that has quickly become the standard procedure for both shop and field installed spandrel insulation. We have the industry's first ASTM E2307 tested solution for hybrid window walls, crossover window walls, and vertical notched curtain wall systems using the revolutionary window wall gasket. As we briefly looked at earlier, STI has also developed testing designs for top and face of slab anchor protection. We have developed the first and only tested solution for 2 hours on a completely exposed under slab anchor system. In addition, we have worked closely with our glazing and consultant partners to develop the industry's first UL-tested solution for sealing the inside of mullions. This is a two-part foam incorporating an intumescent technology that will expand 11 to 14 times for complete protection. It requires no wet sealant or flammable foam in a can. Simply install in the shop and set the units. It has a leakage rating of less than 1 CFM, a noise reduction coefficient of 0.75, 0 VOCs, and obviously it's a UL listed product. These are custom cut for projects, so we will work closely with the design team early on to ensure a seamless install in the fabrication shop. STI's commitment to supporting our customers is never ending. We offer unmatched technical support from our engineering services group with over 250 years of combined experience through 2 US offices, 6 days a week. Our goal is a 24-hour turnaround time on engineering judgments and immediate technical support. Our curtain wall team works daily with our engineering group. As I mentioned in the beginning, I cover the Western US and Western Canada. Aaron Alterman covers the central portion of the US and into central Canada. And Eric LaCroix, who is our director of the curtain wall team, covers the eastern portion of the US and eastern Canada. Combined, we have over 45 years of experience between us. And as we have discussed, our role is to assist in the design of perimeter fire barrier systems with architects, curtain wall consultants, glazers, and fire stop contractors. Once the project is broken ground, we will then assist with the local STI personnel to help deliver a successful project. To make our partners' lives look a lot easier, we have developed what we call a handbook of solutions. And this focuses on our most cutting edge systems. So it's not going to include the 150 plus tested designs that we have. It's going to have the most cutting edge systems that we have. And it's broken down by wall types, insulation attachment methods, and anchor type. So we have back pan, non-back pan, all vision glass, short panel designs, hybrid window walls, and obviously anchor protection. Please feel free to drop any of us an email and we're happy to get it to you. And with that, we have concluded the program and I want to open up the rest of our time for question and answers. I saw a bunch coming in and happy to open up and answer any questions you guys might have.
All right, Mike, thank you very much. Yeah, we do have a few questions that came in here. We have someone else on the panel. We're going to, I guess, introduce Eric LaCroix. He's going to jump in here in case he needs a little backup on some of these questions here. He's the Director of Strategic Accounts. Eric, are you with us? Are you unmuted?
Yes, sir. Can you hear me okay?
All right. Yes, we can hear you.
Great, great.
Mike, you want to flip to that last slide real quick so we can tell everybody what that's all about first?
I was trying to keep my mug off the screen, but okay.
Perfect. We love your mug. We love your mug. So, so now we're gonna jump into the questions. As I mentioned, Eric LaCroix is gonna be answering the questions alongside Mike. But if you could please, grab your phone, hit that QR code, leave Mike some feedback on LinkedIn. Let us know how we did. We're gonna pick a winner to give away one of these bags that's up on there as well. So feel free to jump over there while we go through some of these questions. So I will kick it off here. First question, what is the relationship between the ASTM E2307 with the ASTM E2874? Either one of you guys want to take that one?
Yeah, I can take it if you want, Mike.
Okay.
Yeah, so basically 2874 is a standard that's been introduced primarily through the mineral manufacturers. And what it is they're trying to go back to the possibility of evaluating curtain wall designs for a leapfrog effect. Now, the problem with leapfrog effect is the only way to truly get a rating or any type of protection vertically from vertical separation openings is to increase your transom spacing. And the problem is architects are not going to do that. They're not going to, go back to the old days of where you have a knee wall or a 72-inch panel that's 33 inches off the slab. So with that being said, 2307 is a standard. 2874 is an additional standard that is not part of the 2307 requirement that has been adopted to try to increase the transom spacing, which means the use of more mineral insulation.
Great. Thank you for that clarification, Eric. Christina, you want to ask the next one?
Sure, this is kind of a multi-question one. Can you speak about engineering judgments and what documents make up an EJ? Who is authorized to produce EJs? And are they required to be signed and sealed? And are they free from STI?
Okay, there's a lot in there. So first of all, let me just answer by saying all our technical support for our accounts is free of charge. We don't charge anybody for any type of additional engineering data. So all our engineer judgments and technical support is no charge for our customers. That's number one. What does it take to make up an engineering judgment? First of all, it takes a system that's similar to your exact project condition. You should be, for example, you wouldn't want to use a test that references a precast panel on an aluminum frame design. Makes pretty much sense. So basically what you need to do is you need to have the systems that will support the actual installation on site. So you need to have multiple UL tests or intertech tests with project data that will support the writing of the judgment. And then that is generally submitted to the project, to the architect, to the owners, or in some states like, for example, in Mecklenburg County in North Carolina, in San Francisco, in California, 2 examples, those areas do require often a third-party engineering stamp or review be done. And that's generally provided separately from the manufacturers through the third-party engineering firms, because people don't want the foxes watching the hen house.
Great point, Eric. All right, next question here. Can the spray-on fire or smoke seal be sprayed from below the slab if not available to gain access above?
No, generally, keep in mind that the material is very thin. It's a high production, high performance spray product that dries, that's applied roughly to 1/8 of an inch, that often will cure to as little as 1/16 of an inch. So the important thing is that you need the combination of the mineral wool to thermally protect the seal on top of the slab. If you put the seal on the bottom side of the slab, the fire will burn it off too quickly. So if you do get into a situation where you cannot have access to the top of the slab, there are many easy methods to do that. One is called a sandwich design, where you would pack about 2 inches of insulation into the floor slab from below, spray the material, and then install the 4-inch requirement of depth underneath that seal. So you would still have the required depth of mineral wool protecting the seal, and you'd also be able to install it from the underside of the slab.
All right, thank you. Christina, you got the next one?
Sure. ULCW-D-1041 and most all others never show a steel beam holding up the floor slab. With a steel beam in the way, you can't fasten anything from the inside. Why is that?
There actually are multiple designs that show a restrained or unrestrained beam. You may want to look more towards the precast designs like CWD 2005, for example. They incorporate a beam into the actual design. In theory or in actuality, the beam, whether it's precast or fireproof steel or bare steel or whatever, has no bearing on the performance of the fire stop system. So that's why it's often not included in the tests themselves. But however, oftentimes you absolutely can work around it. There are times where the beam is too close. Hopefully we run into an application like a backpan design where we're just treating the top of the slab. But as Michael had mentioned, there are numerous high performance hanger systems available now. Quick Clip is the one that's most commonly known, which you can actually install many times without any screws. So it actually just snaps on to the framing, which allows you to get up behind the beam, between the beam and the curtain wall assembly itself, and you're able to snap that in very easily with no screws or drills. So hopefully that will, eliminate some of those issues in the field.
Right. Perfect. Why is there not any UL tested assemblies for vertical fire stops, such as where a partition meets the dynamic curtain wall?
That's a good question. That the issue with that is there's actually a code requirement in the IBC code for basically where a partition wall terminates into a exterior curtain wall assembly. The issue is that there is no ASTM standard developed to test this. So if you reference the code section, and if any of you would like further information on this, feel free to email Michael or myself, and we will get you the code section and explain it further. But there's a code section that allows you to install material with known fire resistance property or other fire stop system materials into that application. So STI, for example, has dozens and dozens of projects ongoing right now where we actually have systems being installed, the vertical joint there, and we can help you out with that. But keep in mind, until an ASTM standard is developed, there's no way for the labs to create a furnace to burn off of. So right now, that's why the code allows you to use other materials that have been used in other applications.
Christina, you got that next one?
Sure. Does UL require a partially exposed wind load anchor to be protected?
No, wind loads are not required to be protected, only dead load anchors.
This next one, it says, can you please explain again the installation of mineral wool in the gap before putting on fire stopping? Maybe just a quick high level mineral wool orientation, just kind of the importance of it and whatnot.
Sure. Basically, as Michael had showed in the images, what you want to do is you want to take the mineral wool and you want to turn it with the grains running vertical. Think of it as an accordion. Okay, if you have a flat piece of insulation and you cut a strip out of it and you try to bend it, it's going to bow and bend and really get fatigued. If you take that same strip of mineral wool and you turn it vertically and you add an additional extra piece vertically, almost like an accordion, when you compress that, you slide it into the joint, that will rebound against itself during the testing and the fire. So that's the important thing. And as Michael said, we actually have the only documented test for voids, gaps, whatever you want to call it, at the slab edge, tested at UL for up to 10 inches wide with no support. So that's the importance of turning the mineral wool the right way. It saves an awful lot of money and headaches on the job. In addition, use a lot less spray because the spray isn't absorbed into the mineral wool as quickly.
Great. Christine, I'll take this next one because I'm going to rephrase it a little bit. I think the question is about our spray and how it's affected when in storage. Obviously, it's asking what is the proper storage. They can check the product data sheets, but can you speak about the right way to store it and what happens if, say, our fast tag product is left out?
Sure. Well, all our products, I mean, obviously we have specific products designed for specific applications. The two main ones are a water-based spray, which is called safing spray, or we have another product called AS. But there's also an all-weather silicone hybrid spray called Fast Tack. And obviously they have different requirements. Generally, all water-based products are generally stored in non-freeze areas. If the material does freeze, STI has formulated our product to be able to freeze thaw. And what that means is if somebody leaves our water-based product in the back of a van or a truck and it freezes, it can be, brought up to room temperature and sprayed with no issues. When it comes to Fast Tack, you have a lot more flexibility because you have a lot more temperature, flexibility in what you can spray in. That product was actually designed to be sprayed in freezing temperatures and also basically in the rain, so it will not wash out. So those are very general things, but if you have a specific question about, the storage components, please feel free to send Michael or myself a text or an email, and we'll answer that more in detail for you.
All right, Christina, you want to take that next one?
Yeah, we are seeing a lot more curtain wall designs where the spandrel bypassed the floor slab at an angle. Does this require the safing at the floor line to be mechanically supported?
That's actually a great question. The great news is STI has, as Michael had mentioned, we're doing a lot of real world testing with our partners, both on the consulting and the glazing side. And we recently just passed a series of tests for a project out in California that incorporated, among other things, the first angled wall that's ever been tested. CWD 1050 you can reference. That allows the industry's first angled wall to be done. In that particular test, we did not have to support the insulation. I believe it was up to a 9-degree wall. We do have other projects going on around the country and around the world where they have much greater degrees of angle to the walls. It really depends on the wall, on the angle itself. At times we will support the insulation in the slot. At other times we won't. It really depends on the configuration of the wall and the way the wall is angled. So again, we can refer back to a specific design. If you have anything you want us to look at, send us the shop drawing or the architectural to Mike and to Michael, and we will get you an answer along with the UL system that you can use for that.
All right, looks like we have one more here that we're going to ask. What's the maximum distance between the back pan and the face of the slab for effective fire seals? I know we kind of covered that with the 10 inches of mineral wool without support, but I think this might be asking, is there a maximum distance? I mean, I've seen some engineering judgments where we use extra steel to kind of reinforce, but can you speak to that?
Yeah, it's, the honest answer is it really depends on the budget that's going to pay for it. There, obviously there gets to a point where it becomes impractical and it's cheaper to do a different type of solution. But in general, up to 10 inch, we have complete testing at UL in Intertech with no supports. If we were to go, over 10 inch, then maybe 10 inch to 24 inch, even 30 inches, we would look at using a steel stud under the slab for support. We have several projects doing that right now. And those are generally spaced, depending on the project, between 12 to 18